Hello everyone. In this video, we're going to work through two of the problems in homework number 9. The first one's the theorem, problem number 2L on page 581 out of set 10.2e. So this is a theorem. It says if something is f or something is g, then something is either f or g. I have the scope line set up, and our statement is down along the scope line at the bottom of the proof. And of course, being a theorem, there are no primary assumptions. So I'm going to work through this. I'm going to try to work through this relatively quickly and address some of the mistakes I saw along the way. This statement is a conditional, and so a good way of proving it is to assume for conditional introduction. So we're going to use a conditional proof here. And the first thing that we're going to do then is to set up the scope lines for that subderivation. Okay, there we are. We have to set up our auxiliary assumption, which will be the left-hand side of the conditional, our antecedent of the conditional. It's always that way. So there's an x, fx, or there's an x, gx. That's our assumption for conditional introduction. Conditional introduction also tells us what the last line of the subderivation has to be, and it has to be the consequent of the conditional. There's an x, excuse me again. There's an x, fx, or gx. Okay, so we're going to now look at our new target sentence, the consequent of the conditional we're after, and think about how we might get this. And I'm going to, again, speed things along a little bit. If we look at the sentence we have to work with, it's a disjunction. This is really, really important. Line 1 is not an existential generalization. It has an existential quantifier on the left, but the main logical operator here is that wedge. All we have to work with is a wedge and nothing else to use alongside it. So that pretty much limits us. I'm not saying this is the absolutely only way to do it, but it's a good way. We're going to use the rule wedge elimination. It helps us use disjunctions, and that's the only thing we have to work with. So we're going to use wedge elimination on the on line 1, which is our disjunction. This is a subderivation rule. That means it's a rule that takes subderivations as input. So I'm going to go ahead and set up those scope lines. There they are. On the first subderivation, we're going to assume the left disjunct. Something is f. There's an x, fx. That's an assumption for wedge elimination. On the second subderivation, we're going to assume the other disjunct. Something is g. There's an x, gx. That's an assumption for wedge elimination. The rule also tells us that we have to arrive at the same sentence at the bottom of both subderivations. And we're just going to make that the sentence that we're after. Okay, so there's an x, fx, wedge, gx. And there's an x, fx, wedge, gx. All right? So that's our strategy so far. We're going to prove the theorem using conditional introduction. We're going to get the consequent of the conditional by wedge elimination on the disjunction that we have on line 1. So now what we need to do is think about how we're going to get from something as f to something as either f or g. One thing I'm going to point out very quickly is that we cannot simply disjoin gx inside the scope of the existential quantifier by using wedge introduction, okay? We cannot do that. The reason is that wedge introduction gives us sentences whose main connective is a disjunction sign. And if we look at our target sentence, the main operator is the existential quantifier. So we can't move from 2 to this new target by wedge introduction. Wedge introduction simply wouldn't give us an existential generalization. It'll give us a disjunction, but this isn't a disjunction, it's an existential generalization. So how are we going to do it? Well, looky here. We have an existential generalization to work with, and whether you like it or not, the only way to work with it is by a rule called existential elimination. So we have to, that's a subderivation rule, existential elimination. So what that means is that we're going to have to assume an instance of our existential generalization as an auxiliary assumption in a subderivation. So I'll go ahead and put that subderivation scope line together. And by the way, I'm just going to go ahead and do the same thing in this second subderivation, because we're going to encounter the same problem. We want to move from something as G to something's either F or G, and we cannot do it by wedge introduction. Wedge introduction would give us a disjunction, and our target sentence is an existential generalization. So we're going to end up having to do the same kind of application of existential elimination down here in this second subderivation. Okay, so let's get those scope lines up. There they are. Let's work this out carefully here on the first subderivation and see if it basically shows us what we're going to have to do on the second subderivation. So here on line 3, if we're going to use existential elimination, we will have to make an assumption for existential elimination. That means we're going to assume a neutral instance of the existential generalization on line 2. A neutral instance means that the name that we instantiate to has to be completely new to the proof. It doesn't appear above it, and we're not going to see it below. So that means we'll assume FA. We could use other names. Here we're going to use disjunction introduction, FA, wedge GA. That's line 3, wedge introduction. And then inside the subderivation, we're going to do existential introduction. There's an X, FX, wedge GX. That's from line 4, existential introduction. We have now variables in place of the name A. We have variables in there, and that means that we can now, this is a sentence we can take, basically we can take it out of the subderivation. So line 6 is going to be an application of existential elimination, not on line 5, not on line 4. It's actually on lines 2 and 3 through 5. 3 through 5, that's the duration of our subderivation. Starts on line 3, ends on line 5. We'll take the existential generalization as input, and we're going to take the subderivation that begins with its neutral instance as input. Okay? And we'll export the last line because it doesn't have this name in it. So it respects all the provisos on existential elimination. Let's take a look at the other subderivation. It's going to work in basically the same way. It's going to introduce a name entirely new to the proof, B. So we get GB on line 8 as an assumption for existential elimination. And we're going to do the same 2 moves in there. On 9 and 10, we're going to do FB wedge GB from 8 wedge introduction. And then there's an X, FX wedge GX on line 9 existential introduction. Line 11 then is going to be our application of existential elimination. This time on the existential on line 7, and then the subderivation 8 through 10, existential elimination. Okay, from that brings us to the point where we had planned earlier. We have our target sentence at the bottom of these 2 subderivations. And don't lose track of what we're doing in these subderivations. These are subderivations for wedge elimination. So wedge elimination says you have to have the same sentence at the bottom of those 2 subderivations, and we do now. So this comes from line 1, which is where our disjunction is, our wedge, and then 2 through 6, okay, 2 through 6, and then 7 through 11, 7 through 11, wedge elimination. And so make sure that you see that. This is a disjunction up there on line 1. The subderivation starting on line 2 starts with the left disjunct and it runs to 6, 2 to 6. Line 7 starts with an assumption that's the right-hand disjunct, starts on 7 and ends on 11. Okay, so that's why we have 1 and 2 through 6 and 7 through 11. Then it's time to finish the annotation. Our subderivation for conditional introduction runs from 1 through 12, horseshoe I. And that's how we prove this theorem. This is a pretty standard strategy for proving the theorem. It was a 13-step proof. Many of you took what I would regard as shortcuts on that problem. And so I wanted to point out how it should really unfold. The most important thing is that I think it all went downhill if you didn't recognize that line 1 was a disjunction instead of an existential generalization. Okay, so I'm going to clear this out, and then we will look at the next problem that I think we should see from the homework. Okay, everyone, here it is. This was the 4th problem in the homework assignment, number 6H from set 10.2E on page 582. So this statement, or this argument, turned out to have a few pitfalls in it. I'll just tell you, maybe I'll have an opportunity to explain this a little more clearly as we go along. The problem here involved applying conditional rules to lines 1 and 2. So a lot of conditional elimination or modus tollens, taking lines 1 and 2 as input. I just want to point out that lines 1 and 2 are not conditionals. They do have horseshoes in them, okay? But conditional elimination would not take line 1 or 2 as input, and neither would modus tollens. And by the way, neither would hypothetical syllogism, which is another possibility that you could maybe see. Those rules take statements that are conditionals as input. And when I say that a statement's a conditional, all I mean is that its main connective or main logical operator is the horseshoe. But that's far from the case in lines 1 and 2. So if you applied modus tollens to lines 1 or 2 or conditional elimination, that was a mistake. So usually I like to do some goal assessment. I like to start by, let's imagine how we might arrive at this point by imagining a next to the last point. And we'll definitely have to do that to some degree in our heads a little bit later on. But in this proof, I just want to work it down. I just want to apply some rules right here at the top and just start extending the list of sentences that we have to work with in this derivation. When I look at lines 1 and 2, I see that there are 3 quantifiers, universal quantifiers, which are very easy to work with. When I look at line 3, I see the negation of an existential. In fact, the negation of an existentially quantified existential generalization. And your eyes may take a while to adjust to this, but I actually see this as a universal generalization. It's not a universal yet, but it'll give us a couple of universals to work with. So really we have lots of universals to work with. So why don't we spend some time here at the beginning of the proof, and it is going to take some time, to shed all of those universal quantifiers. And when we get rid of them all, then we can do some sentence logic. And like modus tollens or conditional elimination, depending on which way we want to go. And it's going to take longer, but it'll be right. So that's going to be the lesson of this proof. So I'm just going to start by dropping quantifiers. Let's look at line 1 and do universal elimination on it. Drop that quantifier and with it the outer parens and replace I'm sorry, I've made a mistake. I got to fix this real quick. That should be an X on line 1. I was anticipating what my next move was going to be. Okay, so we're going to drop the quantifier on line 1. And with it, we're going to drop the outer parens, and we're going to replace these X's with the name A. All right, we could choose any name, but we'll just start at the beginning of the alphabet. So this gives us FA, horseshoe, there's a y, g, a, y, right? There we go. We've instantiated line 1. Let's do the same thing to line 2. We can choose any name we want. We'll drop the x quantifier, replace the x's, and there are 2 of them. We got to replace them with names, and we're gonna replace them with the name a. So start with the y quantifier for all y, open paren, g, a, y, horseshoe, h, a, y. That's from line 2, universal elimination. I'm going to pause here for a comment. We could actually input any name, A, B, C, D, any name we want in this position, in this formula. But we're going to want to apply some rules later on. So strategically, we want to name A. And here's why. We have this 2-place predicate G on line 4, and in the first position, there's the name A. So we have the same predicate on line 5. We want the name A there too, because we want there to be a lot of contact here so that these sentences end up talking to each other and we get to apply more rules. If I have the name B here, then I don't have the similarity that the rules will require when it comes to applying rules that say, for instance, take 2 lines as input. Line 6, I'm going to drop the y quantifier, and I'm going to drop the outer parentheses here because we're going to do universal elimination there on line 5. And that gives me G, A, horseshoe, H, A, and I have to have a name here in place of the y's. I could put A's in there, okay? That would be a perfectly legal move. But I'm going to put B's in there instead. And I'm going to put a little, let's put a little green asterisk here so that when we come to the point later on, we'll appreciate why the name here is B instead of A. Okay? But for now, I'm just going to keep moving. Notice, by the way, on line 4, I have a simple conditional, and on line 6, I have a simple conditional. So rules like conditional elimination and modus tollens will take lines 4 and 6 as input, whereas they wouldn't take 1 or 2. So let's look on line 7. We're just going to take a little while to mess around with line 3. The first thing we're going to do on line 3 is hopefully obvious. We're going to apply quantifier negation. So I'm going to turn that first existential into a universal x, and then move the tilde across. Then there's a y, hxy. That's line 3, quantifier negation. And now what we're going to do, we're just going to do the same thing again for all x. Okay, now we're going to take the quantifier and drag it across, take the negation sign, drag it across the quantifier, and change the existential to universal. So we've got a universal y tilde hxy. That's line 7, quantifier negation. It is a rule of replacement of quantifier negation. It's one of those rules that has the 2 little double arrows. So that means we can perform it on part of a line. And so we're really applying quantifier negation to this section of line 7. And that's a perfectly legal move. And now guess what we're going to do on lines 9 and 10? We're going to drop those universal quantifiers. And when we're thinking about what names to use, excuse me, we're going to be looking up here because this is an H predicate. We're going to look up here to this H, and we're going to try to put something together that looks like it. Okay, so for all y, tilde H, A, Y. That's line 8, universal elimination. And then tilde H, A, B is line 9, universal elimination. Okay? So another brief comment here. Stay with me. When we do universal elimination on line 8, we cannot start with the y quantifier. Same way up on line 2. When you want to do universal elimination on line 2, you cannot start inside on the inner quantifier. Universal elimination takes them, like all of these rules, they operate on the main logical operator. So the rule only sees, basically, when a rule like universal elimination looks at line 2, it only sees this quantifier. It doesn't really care what's going on inside or to the right of the quantifier. It cares that line 2, universal x, is the main logical operator, so that's the quantifier that gets dropped. Okay, and the same story down here on line, when we move from line 8 to 9. We can't drop the quantifier inside. It's a secondary logical operator. The main operator is this universal. So we got to make sure that we're not dropping quantifiers in the wrong order. Now, line 11, I'm going to give myself a little gap here and hope I don't regret it later on. It's time for some sentence logic. We've done universal elimination and quantifier negation on lines 4 through 10. That's a lot of table setting. But now it's time to do some sentence logic. And we need to have our eye on the sentences that don't have quantifiers, or don't have quantifiers as main connectives at least. And those are lines 4. Let me choose blue this time. Lines 4, 6, and 10. So if you look at those and say, okay, well, what can I do? What sentence logic rules can I apply here? Many of you are probably your eyes are gonna land on 6 and 10 and say, well, there's modus tollens, right? So tilde GAB. Tilde GAB is from 6 and 10, modus tollens, and it is. So there we go. We've moved extended the list of sentences in our proof. Now, where are we going to go from here? If we look, we had lines 4, 6, and 10. We just used 6 and 10. So now we have 4 and 11. Is there anything that we can do there? And hopefully what you're seeing is that we don't have input for modus tollens. We don't have input for modus tollens. But it looks like we're close. And in fact, we are close. So one thing I would ask is if we had tilde, there is a y, right? G-A-Y. If we had that, let's dream about that somehow. If we had that, we would have the negation of the consequent of the conditional on line 4, and that would give us input for modus tollens. So we could write down the negation of the antecedent, right? So that would be from lines 4 and whatever, modus tollens. By the way, would that be nice to have? Would that be nice to have? Yeah, it would be nice to have. It's not the same, by the way, is it? It's not the same as our target sentence. So we're going to have to figure out how to get there, but it's something to work with. So let me just say this. There's a couple of options. I want to rule one out real quick for you, and that's existential introduction. So let's look at our tilde FA here, and let's see, well, what would it look like if we did existential introduction? There's an X tilde FX. Okay, that's existential introduction. Is that what we want? No, it's not. Could I say that this is existential introduction? Tilde, there's an X, FX, so I'm basically doing existential introduction only on this part of the line. Nope, I can't do that. Existential introduction takes whole lines as input. That's important. The other important thing is that existential introduction gives us a line whose main logical operator is that new existential quantifier. Well, the main operator here is the tilde, okay? So existential introduction is a good thing to think because, after all, what we're after, if you look down there at the target sentence, is an existential generalization. It has an existential quantifier. But existential quantifiers can come into a proof in more ways than one, right? So how are we going to do this? Well, again, by the way, everything I just said about existential introduction as a way to get from here to our target sentence I could have said the exact same thing about the move from tilde GAB to tilde there's a Y GAY. Okay, so I'll save my breath and your time by not repeating it. So here's an idea though. What if I have for all X, tilde fx. Would that be okay? Would that be a legal move? It looks like universal introduction. It looks like universal introduction. So we have to make sure that it's a universal introduction's touchy. So we just need to make sure that the two provisos are satisfied. Here's the first proviso. Is the name A in a live assumption? And the answer is no, despite my slip of the pen earlier. The name A is not in any of the assumptions. No names are in these assumptions. So that means that we can do universal introduction on this line, tilde FA. And also the name A is not in the result of the rule application. Obviously, this was easier to satisfy because there was only one occurrence of the name A. So both provisos of universal introduction are satisfied, so we can get from here to here by universal introduction. And that's a good thing because now we can take that tilde and drag it across the quantifier and change the quantifier from universal to existential. In other words, we can do quantifier negation, okay? So we figured that out. We're home free. This is all okay. We still have the puzzle here. What are we going to do? Well, we got from tilde FA to the universal generalization and then did quantifier negation to get what we want. And maybe that's going to work here too. So let's do universal introduction on line 11. And we'll use the y variable for all y, tilde GAY. That's on line 11, universal introduction. Okay. And then line 13 comes from 12, quantifier negation. Right? Now at this point, in fact, right here is the point that I want to stop or pause and reflect on the wisdom of choosing the name B up there on line 6. Because that choice gave us tilde GAB on line 11, right? That GAB part comes from line 6. It's the negation of the antecedent of the conditional on line 6. And thank goodness we did that, because if we had instantiated to the name A, if we had put an A in there, we'd have tilde GAA. And then we could not get to what we want, because we would be violating one of the restrictions on universal introduction. Universal introduction says that if you replace a name with a variable and add the universal quantifier, that name can't appear in the sentence, okay? So we can fix that easily by simply putting the name B in on line 6. So that was a smart move. Okay, so then on line 14, this comes from 4 and 13 modus tollens, doesn't it? Okay, so we have what we were sort of dreaming here. If we could get this, we would use it to do modus tollens on line 4 and get tilde FA. And then line 15 is universal introduction on line 14, sorry. And then line 16 is quantifier negation on line 15, okay? So that turned out to be a 16-step proof. That was a fairly direct, straightforward way of doing it, although it does involve some SD plus rules. It wasn't the only way to do it, but it's a good way to do it, okay?